So we all know that 8 is 2 to the third, or we should know that 8 is 2 to the third. This is called getting a common base. Once you change this 8 into 2 to the third, then you can forget the 2's and just set the exponents equal to each other. That's going to be our strategy. We're going to try to make the bases, make these two numbers into the same number, and then we can just look at the exponents. So, for example, in the next one, 3 times 4 to the x equals 48. First thing we're going to do is divide by this 3. We're going to get that 3 moved over to the other side. So now we just have 4 to the x, our exponential. And then, what's 48 divided by 3? 16.
Which is 4 squared.
Which is 4 squared. So 4 to the x equals 4 squared, which means x equals 2. As soon as you can make these two numbers the same, then you just set your exponents equal to each other. 4 to the x equals 8. Now this is a tougher one, kids. You got to change them both this time. What's 4? 2 squared. What's 8?
2 cubed.
2 cubed. So we change them both into 2's. So 2 squared to the x. 4 is 2 squared. 8 is 2 cubed. Now, see how they're both 2's? So now we can say 2x equals 3. So x equals 3 halves or 1 1/2. The key to doing these problems without a calculator is to make the bases the same number. So we have 4 and an 8, can't do it, so we change them both into powers of 2. And then we can do it. Okay, let's look at D. Don't get psyched out, it's exactly the same kind of problem. What do you think we might do first? Take a clue from this one. We're going to divide by 3 first. Get rid of this extra number. This extra number, get rid of it. So 4 to the 2x equals 32. Now you got to think about this for a minute, because you need 4 and 32 to both be powers of the same number. What do you know about 32? Do you know anything about 32?
Divisible by 8.
Well, it's definitely divisible by 8. 32 is 4 times 8. That doesn't really help me out here.
It's 2 to the 5th.
Oh, 32 is 2 to the 5th power. Because this is 2 2's and that is 3 2's. So it's 5 2's, 2 to the 5th. So 32 is 2 to the 5th. What's 4?
2 squared.
2 squared. So 4, the number 4, I'm writing as 2 squared. And the number 32, I'm writing as 2 to the 5th. Now, are they both the same?
Yep.
So now I can just look at the exponents. So 4x equals 5. See where I got 4x? And x equals 5/4. Kind of keep track of what do you need to know? What do you need to like write down and star and make sure you know? One thing you probably should know is that 32 is 2 to the 5th, because that's kind of a common one. 2 and 3 are definitely our most common bases that we use all the time. Not in the next problem now, let's look at the next one. 2 times 5 to the x over 3 power equals 250.
Divide the twos.
Divide by 2. Have we discussed how much I do not like these paper straws?
I hate them so much.
No, but I know they're better for the environment,
I
but
hate them.
I don't like the way they feel.
No, the way they taste too.
So divide by 2. So 5 to the x over 3 equals 125. Scout has maybe already knew or just figured out that 125 is 5 to the 3rd power. 125 is 5 times 5 times 5. If I'm asking you to do these problems without a calculator, you are always going to be able to get a common base, guys. So sometimes you're just gonna have to figure it out, but you're always gonna be able to do it if you don't have a calculator. You have to be able to get a common base. So 5 to the x over 3 power equals 5 to the 3rd. Can I drop these out now? So x over 3 equals 3, which means x equals 9. Yep, times both sides by 3. Beautiful, beautiful, beautiful. Okay, this is F. What do you want to do first? Divide by 2. So always get rid of this extra number. Later on in the chapter, at the end of the chapter, we're going to do word problems. And all the time, we're going to have this extra number. You're going to have to learn to divide it out. Get rid of it. So 9 to the x plus 3 equals 27. Now 9 and 27 have to be turned into the same number to a power. So what do we know about 9 and 27? They're both powers of 3. Because what's 9? 3 squared. What's 27? 3 cubed. 9 is 3 squared, so I made that a 3 squared. This right here. 27 is 3 cubed. Now they match, so I can set my exponents equal. Be careful with this one though. This is going to be a distributive, okay? So this one, this exponent is going to be 2x plus 6. Does everybody see that? And it equals 3. So this exponent equals this exponent. Always. That's why we got the bases the same. So subtract 6. And divide by 2. I got negative 3/2 as my answer. All right, will you try the next one on your own? See if you can make any progress with this one. I know it looks a little scary, but let's see if you can make any progress at all. think about what your first step is gonna be. What do you think we'll do first? Quinn, do you have an idea what we might do first? Okay, look what we did here in this last, or in this problem that we did here.
Divide by 36.
Yep, we're gonna divide by 36, that's exactly right. Now, here's the deal, folks. Don't freak out. What do you know about 9 divided by 36?
1/4.
That's 1/4. Okay, now wait a second. Wait a second, wait a second. What do you know about 1/4?
It's a 1/2 to the
Isn't
negative.
it 1/2 squared? Think about that. 1 squared is 1, 2 squared is 4. Do the bases match now? They're both halves, right? They're both halves. So, x over 4 equals 2, which means x equals 8. Now, who has a question about that? That problem's a little tricky. What am I ready for? H? Okay, here we go. Jeanette, what do I do first? Yep, divide by 27, so 1/3 to the x equals 243 divided by 27, is that 9? Yeah. Now what has to happen now? What do I need to do?
Get matching bases.
I need to get matching bases. So your job is to look at, you got 1/3 and you got 9. Can you change them both into what? What can you change them both into? 3s? Can't you change them into 3s? Now be careful, this is 1/3, which means its exponent is going to have to be,
Negative.
not 3, -1. Because what does a negative exponent do? 1/? So won't this change into 1/3? Or won't this change into 3 to the negative first? What's 9? 3 squared. So now I can set my exponents equal to each other, and negative x equals 2, which means x equals -2. Anytime your number is 1/, you know your exponent's negative, because that's how we get 1/, right? And if you decide you're gonna change both of these into 3s, which is a great idea, this is 1/, so it's gotta be 3 to the negative first, and then that one is of course 3 squared. All right, one more in this section. Any idea how how we might start this one. Alex, what do you think?
Divide by 8 or 1/8.
Well, you can divide by 1/8, which is the same as multiplying by 8. So it doesn't matter, it's probably easier just to multiply by 8. So 2 to the x over 5 equals 64. Now, if you're going to do this without a calculator, you have to be able to get a common base. So 2 is about as simple as it gets. So I'm going to have to figure out if 64 is 2 to the something. Okay, what did we just talk about? I erased it, but didn't we have 2 to the 5th was 32? So isn't 64 one more 2 times by another 2? So this is 2 to the 6th. If you don't know that, it's okay, but you have to be able to figure it out. Well, now they're both 2's. So x over 5 equals 6. So x equals 30. X equals 30. We just did 1, 2, 3, 4, 5, 6, 7, 8, 9 problems that are all virtually the same. We get rid of this extra number, and then whatever we have, we gotta turn them into the same base. All right. Now we're going to solve some logarithmic equations without a calculator. Now some of these we've already done. Look at this one. Log base 7 of 49 equals x. We already did this kind of problem. Does anybody remember how we do it? We log roll it, or loop-de-loo it, or whatever vocabulary you use. 7 to the x equals 49. 7 to the x equals 49. Remember doing this the other day? 7, start with the base. Always start with the base. 7 to the x equals 49. Just move around. Well, can you tell what that answer is without doing any extra steps? 7 to the second. So x equals 2. 7 to the second is 49. Log base 2 of x equals 3. Can you solve that one? What's that one say? Well, it says 2 to the third equals x. Always start with the base. 2 to the third equals x. So what's x? 8. Easy peasy. Now, do not be frightened. This problem is exactly the same concept. You're not on your phone, are you? Huh?
No.
Okay. Here we go. We're gonna loop-de-loo this. How's that work? What's that gonna say?
4 squared.
4 to the second equals x plus 2. What's 4 to the second? 16. To solve this, all we have to do is subtract 2, so the answer to the problem is 14. These are so easy, but you have to remember this loop-de-loo thing. Okay? Try D on your own. See if you can get D. It's exactly the same kind of problem. Exactly. Olivia, what was the first step of your work here for this problem?
I did the log roll thing, so I put 3 squared equals 1 minus x.
What do the rest of you think? Is she right?
Oh, that's really good.
And of course, we all know 3 squared is 9. So now we have to solve this equation, and it's a little bit backwards, but we're not gonna let that throw us. Don't we need to subtract 1 from both sides?
Yeah.
So when we subtract 1 from both sides, we get 8 equals negative x. And then we'll divide by negative 1, so x equals negative 8. Got it? Now look at this one. This one has a little bit different first step. What do you think the first step might be?
Divide by 2.
Divide by 2. We gotta get rid of, remember how in the other ones we just did, we got rid of this extra number, step 1? It's always step 1. No matter what kind of an equation it is, it's step 1. We're gonna get rid of that. So we're gonna divide both sides by 2. Now when we divide by 2, this cancels, everything else stays the same. So log base 4 x plus 1 stays the same. Then this becomes 2. And then Sandra, what do you think we'll do now?
Switch.
We'll switch things. We do our loop-de-loop thing or switch things. So we start with the base always. So 4 to the second equals x plus 1. 16 equals x plus 1, so it looks like x equals 15. Oh my gosh, this is so easy. Let's look at the last one. Looks kind of big. Negative 3 log base 6, 4 plus x plus 6 equals 0. Xavier, do you have a thought about how we might start this one? Just the first step, what might we do? What'd you say? Okay, we can divide by negative 3. That's a little tricky because you have to divide each term of the problem. So we're gonna divide this by negative 3. We're gonna divide this by negative 3. And we're going to divide this by negative 3. So this is all one term, but this is separate because of the plus, and of course that's the other side. So we have log base 6, 4 plus x, minus 2 equals 0. It is okay to start that way. I probably would not have started that way myself, but it is perfectly okay to start that way, as long as you remember this has to be divided by negative 3 also. This is all one term, so this is untouchable, but that has to be divided. All right, now what? Now we don't have a choice. Now we have to do something next. Sandra?
Do we add the 2?
We absolutely add the 2 to the other side. I probably would have moved the 6 in the beginning of the problem and then divided, but it doesn't make any difference. No matter which order we do it, we're going to get to this point right here. Why do we need the 2 over on that side? Because we're going to loop-de-loop. Loop-de-loop is the only way to get rid of that logarithm. So we're going to loop-de-loop. But we can't loop-de-loop unless we have that number on the other side. All right, so here we go. What's it say when we loop-de-loop? 6 to the second equals 4 plus x. Well, we all know, I hope, that 6 to the second is 36. And we need to subtract 4 from both sides. Did you get 32 as your answer?
Yep.
all of these problems that we just did in this little section, we loop-de-looed every single one of them. But before you can loop-de-loo, you have to make sure you have this gone, and you have to make sure there's nothing else hanging around out here. If we had this -2, we gotta get rid of him before we loop-de-loo. Okay? Well, things are looking great till I look at number 3A. What is wrong with number 3A?
It's not a perfect square.
There is no way to turn a 7 into a 3. Like if it were a 9, 3 squared, but it's a 7. There is no common base for 3 and 7. Would you agree with that statement? So we cannot do this problem without a calculator. We are going to need a calculator to do this problem. Now, how do we do that, even with a calculator? Well, the issue is, like, let's just look at this equation right here. This was easy to solve, because all I had to do was subtract the 4 from both sides. When x is an exponent, things are a little tougher, because I'm not just going to subtract something. I've got to figure out how to get that x down into the problem and not clear up here as an exponent. So what I'm going to do, watch this, you are going to be awed and amazed. I'm going to take the logarithm of both sides. So I am physically going to write log on both sides of the problem. And then I'm going to remember one of my properties. Last time we were together, or maybe it was the time before, I had you write down 3 properties of logarithms. And one of those properties tells me what I can do with an exponent. Who remembers what I can do with an exponent?
Put it up front.
Put it out in front. So now I can write this problem as x log 3 equals log 7. The most powerful, beautiful thing, in my opinion, about logarithms is you can pull the power off. And now, to get x by itself, I'm just going to divide both sides by log 3. So what will I type into my calculator? Log 7 divided by log 3. When I type that in, remember you have to close the parentheses. So log 7, close parentheses, divided by log 3. And I got 0.4032, is that what you got?
I got 1.7.
I got 1.77.
Oh, because I multiplied instead of divided, thank you. Log 7 divided by log 3, I got 1.77. 1, 2, does that look better?
Yeah.
Thank you. Gotta type it in right. Now, just for fun, as a little check here, let's go back to the original problem. This was the original problem. Take 3 and raise it to the 1.7712 power. So type 3 raised to that number. And do you get 7?
Yeah.
You don't get exactly 7 because we rounded this off, but don't you get real close to 7? Yeah, we just checked our answer. This is the answer to the problem. We just checked it because I wanted you to see it works. It really works. It's so cool. So cool. All right, let's try the next one. 4 to the x equals 10. Do 4 and 10 have a common base? No. Now, sometimes we get confused. Mrs. Ford, they're both even numbers, they're divisible by 2. Yes, but when we say a common base, we mean to a power. So this is 2 squared. Is 10 2 to anything? No. So you can't do this without logarithms. So take the logarithm of both sides. And then why did we do that? What is the beauty of that? The x is gonna come out in front. So x log 4 equals log 10. Then what? Divide by log 4 and go to the calculator. That's right. Let's see if I can get this one right. I got 1.6610. How'd I do?
I got 0.6. 0.05.
I got that. I got what you
I
got.
got
I know what you got too.
1.66096.
I did log.
If I'm rounding here,
Log 4.
doesn't that have to go up to a 10?
Oh, I did log 4 over log 10.
Okay, that would be wrong, right? It's, we're trying to get x by itself, so we're dividing by log 4.
Arithmetic.
Human error. Alright, next. Obviously, no common base here. These are random, weird numbers. So to solve this, we're going to take the logarithm of both sides. Would everybody agree? Okay, you have 2 choices. When you see this x up here in the exponent, your 2 choices are, you make it look something like this, common base, or you use logarithms. You're not going to get a common base with these 2 numbers, so we're going to use logarithms. Both sides. Never just one side, always both sides. So the exponent comes out, so x log 1.73 equals log 9.72. And then what are we dividing by? The one that's hooked to the x, right? You're dividing by this one because you're trying to get x by itself. Look at that, guys. We don't want to make a dumb mistake. So type that in. 4.15? Is that right? That sounds awfully good. Oh, it is right. So x equals 4.1491. I don't think there were any directions, but I'm rounding to the 10,000 because that's what we did before on our calculator. Okay, men, are we following along here? Okay. All right, D. What do you think about D?
Divide by 6.
You divide by 6. Guys, this is no different than before. You don't want to have this random extra number hanging around out in front. Divide it out. So now we have 2 to the x plus 1 equals 3. Now those are nice numbers, but can you change a 3 into a 2? Now if it were a 4, we'd be all set, because 4 is 2 squared. But a 3 we can't handle, so we're going to log both sides. Why did we do that? What value does that have? It's the coolest thing ever in the whole wide world. This comes out in
Oh,
front.
fun.
So x plus 1 log 2 equals log 3. What do you think? Now, we have options here. What's an option you can think of? Well, could we divide by log 2
I would do that.
like we've done in the previous problems?
Yeah.
Could we do that? So then, we can type that in on our calculator. The difference is, so log 3 divided by log 2. I got 1.5850 when I divide.
Yep.
The difference is, that is an x. What is that? It's x plus 1. So now I have an extra step. To get x, I will subtract 1. So x equals 0.5850. So that is probably the easiest way for you to do this. You could also distribute, but then you just have more decimals to deal with. So I would probably just go ahead and divide by log 2, just like we've been doing. But then recognize that that equals x plus 1. So you gotta subtract the 1 to get your final answer. All right, what am I ready for? E. 81 e to the x equals 200. Divide both sides by 81. Oh, it's the first spam call I've gotten all day, so that's good.
You can block the numbers, there's like a setting.
You can block numbers. I block every one that comes in, but they just keep coming with different numbers.
I can show you. It's like a, you go like the.
I can block spam period.
Yeah, I turned it off because I kind of like answering it and like messing with it, but you can block it.
I didn't know how to do that. All right. Now what? You can make that a decimal. I would rather not because then I have to round it off and write down all those digits, and I just don't want to do that. So I'm just going to leave it 200 over 81. What do I need to do?
Put the X in front.
How do I put the x in front? I need to log both sides, but guys, since there's an e in the problem, maybe instead of LOG-ing both sides, I will ln both sides. Now, I am allowed to do that. ln is a logarithm. Anything I can do with log, I can do with ln. All right? But here comes something really beautiful. We're going to pull that exponent off. Now I want you to look at this right here. Can anybody tell me anything about this? This ln is log base e of e to the first power. What does log base e of e to the first power equal?
1.
1. Guys, anytime an ln and an e are touching each other, I mean, actually touching each other, nothing in between. Anytime ln and e are touching each other, they cancel. Anytime, they cancel. They make a 1, which is like canceling. So the answer to the problem is just ln 200 over 81. If your problem has an e in it, ln both sides, because this is always going to happen if it has an e in it. So ln 200 divided by 81 equals, did you get 0.9039? Type that in, make sure that's what you get, because that's the right answer, I think. Three more to go and I'll stop. All right, everybody get 0.9039? All right, next problem. What are we gonna do first? Take a look at this one, think about all the things that we've done so far. What's the first thing we're gonna do? We're gonna divide, right? We're gonna divide. So e to the x equals 93 over 17. Right? Michael Browning, Gulf Shores, Alabama. What kind of a college is that? And Xavier, you know how I feel about that jacket and you're wearing it again? Oh yeah. Yep. Don't forget when you're in classroom. Are we all wearing lanyards? You can't wear your coat either. You got your lanyard on? Guys, this is ridiculous. We have logarithms to do and I'm messing around with uniform issues. You guys know the uniform. All right, here we go. What am I gonna do to solve this? What am I gonna do? I'm gonna ln. Now, could I log? Could I log? Absolutely, but it's more work. If there's an e in your problem, ln. Because when you pull this exponent off, what happens right here? When I bring this out in front, what do I have right here? I have a 1. You're gone. So x equals the natural logarithm of 93/17. And that will be ln 93 divided by 17, 1.6994. Two more problems. At least this first one looks kind of scary. Don't be afraid, guys. Do not be afraid. What is step 1? You know this. Divide by 50. And this time I can actually divide because 200 divided by 50 is 4. So it actually goes in. If it doesn't, it's no big deal, but it does. Now what? ln, I'm going to ln both sides. That exponent is going to come off. But when I do that, it leaves me with this, which is gone. Anytime an ln and an e touch each other, gone. So now I'll divide ln 4 by negative 0.112. Does that make sense to everybody? Because I'm trying to get x by itself. So ln 4, close parentheses, divided by negative 0.112. I got negative 12.3776. I need somebody to confirm that, please.
Yep.
That's what you got. Makes me happy. The first few problems I did, I LOG'd both sides. Now I'm LNing both sides. When do I LN both sides? When there's an E in the problem. So the next problem has an E in it. What will I do first?
Divide by 3.
Divide. So E to the 0.17x equals 19 thirds. Now what? ln. These guys are touching each other. 0.17x equals ln 19 thirds. Divide by 0.17. Now be real careful with this, guys. We haven't had one where we had to type quite that much. You're going to type ln 19 divided by 3, close the parentheses, and then divided by 0.17.
10.
That's what I got. 10.8578. We are not done with this section. You may be able to do a few of the homework problems, but we're not ready to do the whole thing just yet.